Well, hello everyone, and welcome to Buddy's Workshop. Now, this is the second channel for the radio shop, and if you never visit the radio shop, I'll leave a link down below. But the radio shop mostly consists of electronic repairs, tutorials, mostly on old vintage radio equipment, ham radio, different things, you know, old AM radios, test equipment, so forth. So I decided to make this second channel, and after looking at some of the comments, I decided to just call it Buddy's Workshop for now. Could change, we'll see. We'll just see how it goes. But mostly today, what I wanted to share with you is the old SpeedWay mill drill that I purchased back in the early 90s. Now, the thing works good as a drill, no problems at all with that, but I wanted to be able to do more milling with it. The old machine has a moist taper 2 arbor in it, so you can change that, you know, the tooling using moist taper 2. Now, one of the biggest problems out of several with this machine is that there was no fine feed for the quill. The quill, you know, you got your handle on your side that you turn, the quill comes down. You can raise the whole head up and down on the machine, but there just wasn't no fine feed for that quill. So that's what we're going to talk about today, and what I did to finally overcome that and make this into a more usable milling machine. Now again, I purchased this old machine back in the early 90s when I was racing go-karts professionally, and I needed something that was a little more features than just a standard drill press. So I went to a tool sale and found this. It was under $500 at the time, and I bought it and didn't have a manual with it, and the box was damaged, but everything was in there except the manual. Someone had removed the manual, so I got the machine a little bit off what the normal price was. But it's the DTMACH34-03989. And it has your movable tables on it. The head moves up and down by this column, which is you have to keep it locked. You can't use the head system to do anything with, because it rotates, you know. So there's no way to solve that unless you go in and do some boring and put a bar in there to make it more secure. And then the crank mechanism isn't the best on it, so you pretty much, you know, put it at height, lock it down on the other side, and then use the quill. Again, like I said, there's no way to put a fine feed. So like if you're going to mill something, you want to take 5 thousandths, 10 thousandths off, there's no way to do that in a fine without using the crank system on the side to feed the whole quill down, which is a problem because there's a little bit of backlash in this, and you kind of got to, you know, measure it and turn it and lock it down on the other side and hope that you got it right. But let's take a look at the mill itself. So again, as you can see, I'll unlock the quill. That's supposed to be a mount over here with a spring in it that returns this up, and I have that off at the moment, but we'll show you why in just a second. But you know, this is all you got to set the where the quill is. So you move the whole head up and down, lock it in place, and then use this to find feed, and it just didn't work that great. So on this side is where the spring return goes. It has a shoulder that goes up in here to keep the spindle here aligned, and then it just tighten in with a set screw under the bottom. There's a big spring round in here so that when you pull it down it brings the quill back up. Well, I made this bushing one in here and put the set screw in there that holds the spindle in place. If you notice, I also drilled 2 holes here, and there's 2 bolts screwed in there. Now this is the lock that locks the quill, as you can see. So I needed some kind of way to be able to turn this real finely to move this spindle up and down. So I'll go ahead and get into it and show you exactly what I did. So over here on this side of it, you can see where that a round so on this side is where the spring return goes. It had a shoulder that goes up in here. It has a shoulder that goes up in here to keep the spindle here aligned, and then it just tighten in with a set screw under the bottom. There's a big spring round in here so that when you pull it down it brings the quill back up. Well, I made this bushing one in here and put the set screw in there that holds the spindle in place. If you notice, I also drilled 2 holes here, and there's 2 bolts screwed in there. Now this is the lock that locks the quill, as you can see. So I needed some kind of way to be able to turn this real finely to move this spindle up and down. So I'll go ahead and get into it and show you exactly what I did. So over here on this side of it, you can see where that a round so on this side is where the spring return. So here's the vise that I made, and it was all made with scrap parts just laying around, and cut everything, build it, and put it on a lathe, turned some parts, and made this device to be able to bolt to the side of the machine. You see the collar sticking out here that spindle goes into, and then basically you turn this knob and that rotates the inner collar and moves the quill up and down. Now if you notice, there's a lever on this side. This is engaged, that's disengaged. That way you can use to drill mill by using the standard quill feed. But then when you need to fine feed it, you pull this up. That locks the worm shaft onto the worm gear, and now you can use this. This is the spring collar that goes on there that brings the quill back up. So we're going to take this thing apart so you can see more on it, and we're going to reinstall it back on the machine. Okay, so we'll go ahead and start disassembling this. First thing we're going to do is take this end cap off. And all this is stock to the machine. Now you can see that spring assembly, how it works. We'll go ahead and remove the spring mechanism. Go ahead and take all the screws out of this little cover. Now remember, all this is just prototype, and was just kind of building on the fly, taking them, looking to see what we needed, making the part, mostly by using just hand tools, drilling, whatever. And this cover is just mainly just to keep dust and stuff from dropping down onto the worm gear. It's a little bit cool in here. The garage, I have a kerosene heater out here, and I'm out of kerosene, so I need to go get some. We can take this off. You can see now this big gear inside, which was hobbed out on the lathe using a tap. I'll pop in a little video clip of that. I didn't video any of this, designing this, because it just took so long, and you know, making decisions on how we're going to do it, trying this and that, taking it apart, scrapping an idea, going back in it with something else. So basically this is an old hub that hold a wheel onto a go-kart axle, and I milled it and bolted this up. Now the had to make a bushing to go in the back of that to fit the shaft in the bottom. Now on the back you can see the lever lock, and when you turn it, this spring on this pin pushes this shaft down, which pushes the whole shaft for the worm gear and disengages it. To lock it back, push it up, it pushes it back up. I got it set so that it engages into the gear in here without any slippage, and when you rotate this, it turns the whole shaft. Okay, let's go ahead and finish taking it apart. Now, something that I do want to do, I'm going to make a collar that's going to bolt up to the front, and I want to graduate this knob. And you know, that way that if I want to take 5 thousandths off, I know exactly how far to turn it to get 5 thousandths or 10 thousandths, 50 thousandths, or whatever you want to do. And this will slide right off. You see there's the shaft. It's just a piece of keyway bolted to it that'll probably eventually be welded on and filed down and corners rounded just a bit. And then this is the shaft and the worm gear itself. And you can see the spring system here. So it ain't nothing that's, you know, very complicated. It's just something that took a while to figure out how to get to work and put it together. So we're going to go ahead and mount all this on the machine so we can test it out. Okay, so to put this on the machine, I'll have to remove these 2 bolts. These are 4mm threads. Then this mechanism, Just fit right on here. Tighten down. Okay. We can put a little lubrication on this shaft. And slide it over, and that's where it just fits up in this boss that holds the gear aligned. And then I have a set screw to tighten it onto the main shaft if I get the right Allen key. Alright, okay, put some lubrication on the gear. A little lubrication on the spring. Now we can put our outer assembly on. Line up this pin in the back. There it goes. Get all 4 bolts started before we tighten it up. Okay. Alright, now we got this bolted on. We can put our spring retainer on here. Loosen up these bolts a little bit. That shaft will align. There we go. We got to rotate this. Go ahead and get this cover on. Keep that spring from flying out into oblivion. Make sure the wheel's unlocked. Okay, I got a dial indicator set up so you can see how slow it moves, and I've already got it engaged, so all I got to do is just rotate this knob. This is again what I need to get. I want to make a boss to go up here and you can graduate this dial, but I couldn't do it till I get it set up to see what the dial indicator reads and how we're going to mark it on the dial. This is just an old stereo that I had, so I'll go ahead and turn the dial. And that's 10 thousandths, 20, 30, 40, 50. And you just pretty much set it to whatever you want. And right back around on 0. Then you can back it off. And that's just going to help for making more accurate cuts on when you're milling something, or when you need to drill a hole at a specific depth, or mill off a determined amount on your stock. This will surely makes this more functional now from what it used to be. Let's just put it that way. So guys, I think this is going to work out okay. You know, like I say, it's just all scratch built just from junk parts around. And when you make your depth that you're going to cut with the dial indicator, then you just lock the coil down, and that'll hold it from moving. So you know, again, this is a big improvement from what I did have. I went from not having any type of fine feed to this kind of crude system. But I think it'll work out alright. So one of the other things I'm going to do is put a, probably one of those cheaper Chinese DROs on the machine. The X and Y position shouldn't be no problem. Getting the scales on here. It's the Z position that will be a little challenging to. I'll have to come off of something here. Probably can mount it to this big ring here and then come up on the side of the machine with it, I believe. But I'm gonna, you know, get one of those and try it out on this machine. Then I don't have to worry about the scale up here on the fine feed. Now one other thing that I want to do is, this machine is belt driven. As you can see, it has 2 belts. So to change the speed, you have to move these belts around, and that's time consuming. Actually thinking about doing away with all this and putting a a different motor on here with a variable speed control. So I'll be looking into that also in the future. So when that time comes, you know, we'll do a video on that. So any ideas of what y'all guys seen in the past, if you don't mind sharing it with me, please do. You know, leave those comments down below. Again, to do the coarse fine on the head, you have to unlock this lever and then go to the other side and crank it up and down. I wish that I could fix it so it didn't have to do that, but I don't want to risk this material. I thought about, you know, bolting a piece of square stock down it and then getting someone to mill out the inside of this so that square stock will fit. That way it'll hold this thing more rigid. I mean, just hand tightening it. But now, every now and again it'll still slip, so I have to put something on it and give it a little cheat. And you know, and that is stressing this a little bit to do that, but I don't know, maybe sometime in the future I'll just replace this whole column with something different that will make it you know, a lot more acceptable, and just bolt the head directly to whatever I put in here. So I'll have to think about that. So guys, that'll pretty much wrap this video up on the old SpeedWay series milling machine. Again, I think just that one modification will help this out a whole lot and be able to make some better milling cuts with it. We'll do some videos in a later future. Now I got this old cheap Harbor Freight vise on there, and I just use that for just regular drilling and some light milling. When I go and try to do some more precision milling, I've got this other brand vise. I cannot find a name on it. I don't know who made it. It's a nice heavy duty vise, and it works pretty good. But one thing I do want to do is mill off the top of this a little bit and get it more precision. Someone has hit it with drill and like to hit it with small end mill, get this mill down. Once I'm you know, pretty sure that everything is going to be accurate on this machine. Also, this is a it's not a fixed jaw vise. You can see when you turn it, both heads move, and that kind of works out pretty good for this machine. Now this table on this machine doesn't have but basically 2 T-slots on it, so I had to drill 2 holes to mount a vise to it. As you can see right here, I just drilled 2 holes in the middle of the table, got them spaced out equally, and with this vise I can loosen up and move it back and forth to get it like I want to hold whatever stock I am. On the other vise, you know, it's got milled out slots on either side. Anyway guys, made some improvements on the Harbor Freight lathe. Got the new tool post, got a 4-jaw chuck. I've already done the video on that. I also modified the compound, the top slide. You can see there's a lot more screws in here to hold the gib. Same thing with the cross slide. There's been more holes drilled. I already got the video done on that. I'll get that up as soon as I can. Another modification I need to make to this is put a carriage lock in here. There's no way to lock the carriage without turning the lead screw off and locking it with the half nut, and even with that you still got some play in it. So we want to put a proper carriage lock on that, and I'll do a separate video on that anyway. Well, until the next video guys, I appreciate y'all stopping by and watching. Like I say, I'm no professional machinist. I'm just a hobbyist. I've ran CNC machines and lathes and milling machines at some of the other places I've worked at over the years, and again, I'm no professional, just a hobbyist. Anyway guys, we'll see you in the next video. Bye now. So guys, that's my prototype design. I know there's several people that has these. I've seen it posted on some of the websites, machining websites. So when I get the time, I'll tear all this back down and draw it up on how I did this and try to make some blueprints on it, on this particular design, in case somebody else wants to build something like this to put on their SpeedWay series drill. You know, probably can even work on some drill presses. I think I've seen some drill presses with a similar type of recoil spring on the side, so that gives you a shaft sticking out. So anyway, we'll see what we can do about that. And when I get it drawn up, I'll post it over on my website at gokarters.com.